Welcome to a new test and teardown video. Yes, it's some more Impo electronic. This one is a Geiger counter. And it is, of course, as always, with Impo, some stuff made for schools. I had this for many years and I did a little bit of modifications to it. I think you can screw in some sort of a holder for your radioactive samples, and then you can adjust the distance to the sensor by loosening this screw and then move your arrangement closer. And then there's this filter. See, there's a tiny little hole here. Or there's full access to the sensor like that. You can even see it bends in if you're really careful. I don't know if this is so visible, but it does actually bend in a little bit. And it's because there's of course a vacuum in there, and this big window actually bends a little bit in to the vacuum. So that is quite funny. And here's the loudspeaker. This one was originally designed for external power supply, but I modified this directly to work with mains voltage. Connector for a counter, or you can put in a counter voltmeter as well. I don't actually understand why we have this big empty space here at the bottom. It's not for batteries or anything like that. This is just the way the design is made. And then there's this hole here as well. I think this is of course for those metal sticks for holding your samples and stuff. So let's look a little bit inside. So here's the loudspeaker. It's connected directly over the counter output, and then there's also a banana output, remember, also for counter output. So what I've done is I cut the wires to those bananas because it's just too easy to connect something to those, and then you're gonna have a problem. And I will explain in a second why you're going to have a problem. And that is, of course, if you look at my power supply here. Normally, this thing is supposed to get external 500 volts directly into this circuit board. But I don't really have a 500 volt supply. And we had plenty of space inside this case, and it's not really using a lot of power in this 500 volt input. So I just took two AC mains transformers. So the first one here you can see is connected directly to mains, right? And then the low voltage side is connected to another transformer, and then it's now generating an isolated mains output. But that was not enough. So what I've done is I took this mains output here and connected it in series with the other the mains input to the first transformer. So now it's all about rectifying the two that is now in series. Here we got the diodes for the bridge rectifier, and then I store my 500 volts on this capacitor, and that goes of course into my circuit board. The circuit here is very simple. It consists of some very high value resistors and a 47 volt Zener diode and then a capacitor. So this is running on 47 volts. It takes a little while to charge this capacitor because of all the very high value resistors, and that is the voltage this circuit here is running on. So it's charging a capacitor, and then it's discharging that capacitor directly through the loudspeaker every time there is a signal from the Geiger tube. So there is a strike through that Geiger tube, so there's a current, and this peak is amplified, and then the energy from the capacitor goes to the loudspeaker. So it's a very, very simple circuit, and it's more or less the same in all Geiger counters you find in the old days. Let's look at the Geiger tube. I don't know if we can see the type number here. I don't really know that number, so it's upside down, right? So it's VIO or something else, right? KOB. I don't know. Normally with Impo products, you're able to see a sticker or some stamps or some date codes, but it's not. I don't find it in this product. See, here it says 500 volts, Geiger counter, Impo, and this is the output. Yeah, it's quite simple. What I should have done is I should of course have made a voltage doubler on the output from this second transformer, but then I needed more capacitors and more diodes and stuff. But then I would have a completely isolated circuit, and then I could use the output for the counters and stuff like that. So right now, if you connect something to that output, you are actually maybe connected directly to phase of your mains. But I know this, of course, so this is why I don't connect anything to it. And that is why, for safety reasons, I cut those wires. So yes, this is my Geiger counter, and I'm super happy about it. I got this many years ago. One of my friends found this in a dumpster dive, I think it was. A school electronic trash dumpster dive. And yeah, I've been using it ever since. So let's try and play with it. So now the Geiger counter is running, and as you can hear, it's a very loud click. So I think the only legal radioactive source, I mean normal electronic guys have access to, that is those alpha emitters from smoke detectors. In old days, smoke detectors, they were using radioactive emitters, and I actually don't want to touch this, and of course you don't eat it or drink it or anything like that. But I think it is very weak, and it's only an alpha emitter, and as you can hear here from a distance, it's already so yeah, this is radioactivity. A little radioactive source. So if I put a counter on this and count how many clicks per minute or per hour or per whatever I want to do at a certain distance, I could compare the level of different emitters. And I got another one from another smoke detector, and this one looks actually quite a lot different. If you look at the material in here, this one is very made in a completely different color, and this one is more shiny. I don't know if I'm able to show this on the video, but they are very different in appearance, to my eyes at least. So let's try the other one. To me, it seems like it's exactly the same. So, at least with the Geiger counter hit like this, or Geiger detector. This one is not counting anything. I don't know exactly why I count or put in counter, but it's not counting anything. It's just radioactive detector, right? But anyway, that is all I wanted to show you in this very short video. Another little Impo product. So thank you very much, and please come again soon. Bye bye.